Okay, example 5 is all about a child playing with a yo-yo. So to get us started, I've drawn a nice little picture of the child playing with his yo-yo. There's a nice pink yo-yo there. And it tells us that the yo-yo can be modelled by this equation here. And that's the displacement from the child's hand, the distance, from the child's hand, because we're working in one dimension. And it says that after t seconds, the distance is given by 0.6t plus 0.4t squared minus 0.2 t cubed for t between 0 and 3. And the first thing they ask you to do is justify the restriction. So if we're going to justify the restriction, the first thing that I'm going to suggest when we're looking at a function like this is we are going to draw the graph so that we can see what the function looks like and therefore see why they might have restricted it for between 0 and 3. So to draw a graph, the first thing we're going to do is look at what type of graph it is. It's a cubic. It's a cubic with a negative value of a, that's the coefficient times in the t cubed in this case. So if that's a is less than 0 and it's a cubic, we should know from our work in pure maths that it's going to look like that. It's going to be an S shape, it's going to start in the top left and finish in the bottom right. We also know that when we draw it, we want to find the key points being where it crosses the axes. So let's start off by saying when s equals 0, this will tell us when it crosses the s-axis, when it crosses the t-axis. So let's find out the roots of the equation, 0.6t plus 0.4t squared minus 0.2t cubed. And when I look at this, there's two things that I notice. The first thing being that there's a t term common in every single part, so let's deal with that first. So 0 equals t taken out as 0.6 plus 0.4t minus 0.2t squared. So this then tells me that either t equals 0, right, which isn't, so it goes through the origin when s is 0, t is 0, or this quadratic equation that we have here is equal to 0. Now, there's two things upsetting me about this quadratic. The first one is the decimals, and the second one is that I've got a negative t squared term. So I'm going to times it all by 10 to remove the decimals, and at the same time I'm going to times it by minus 1. So I'm going to times it by minus 10, and that will flip all the signs and it will get rid of these decimals. So I end up with 2t squared minus 4t now because I've changed the sign, and minus 6 here. Then we can divide by 2, t squared minus 2t minus 3 equals 0, and then we should see that actually this factorises quite nicely. T minus 3, t plus 1 is 0, so t is positive 3, and t is minus 1. Okay. That then should allow us to sketch this graph, so we know the shape and we know the key points where it crosses the axis. So I'm going to mark on my values that I've just found. This is 0, 3, minus 1, and I know from that value of a that it's going to come down and go like that. It's going to come down here, go up, and then down like that. And this is minus 1, 0, and 3. And this is the t-axis here and the s-axis here. So we've got my function, and we can see where the restriction comes from now, right? Between 0 and 3 is the only time, so obviously when we're looking at time, so firstly, it's t bigger than or equal to 0 because we are dealing with time. Okay, we don't deal with negative times, do we? And we stop at 3, so t is less than or equal to 3 is the other part of that restriction, because that's when the yo-yo is a distance of 0, because it goes back to the axis, so it's 0 meters away from the child's hand. So this is the child, throws the yo-yo down, the distance increases, then at this point it starts coming back, and it reaches his hand, a distance of 0 from his hand, when t is equal to 3. If we were to go on, this would then show us that it's got a negative distance. We can't have negative distances, we can only have negative displacements. But also the question says it returns to the child's hands. He doesn't do some magic trick where he throws the yo-yo up above his head after that. So that's when the yo-yo returns to the child's hand. Okay, so that's why we have that restriction. And the way to do that is to show it using a graph. Part B asks us to find the maximum distance of the yo-yo from the child's hand. So we're looking to maximise our value of s between 0 and 3. So on our graph, again a graph is helpful for this, we can see what's going on. We need to find that point. I need to know the s value there. And hopefully we remember our differentiation work, and we know that to find a maximum value, all we have to do is differentiate. So we take our function s equals 0.6t plus 0.4t squared minus 0.t to t cubed, and because I want to find the maximum value, I'm going to differentiate it and I'm going to put it equal to 0. That will tell me the values of t for when it's a maximum or a minimum. So if I do ds by dt, right, because I've differentiated with respect to t and I'm differentiating s, I get 0.6 plus 2 times 0.4, which is 0.8t, and then 3 times minus 0.2, so I get minus 0.6 t squared. Okay, again I get a quadratic. I put this equal to 0 because we're finding a turning point, right, a stationary point, so we put the gradient equal to 0. And again I've got a quadratic, but it's not a particularly pleasant quadratic, so I'm going to times it by minus 10 again because I want to eliminate the decimals and I want to have a positive value of t squared. So this then becomes 0 is equal to 6t squared minus 8t minus 6. So then I divide by 2 as well because I can now see I've got a factor of 2 and I end up with that quadratic. Unfortunately, that quadratic does not factorise, so we're going to have to use the quadratic formula. So I pull out the quadratic formula, I put t equals minus 4, that's minus b, square root of minus 4 squared minus 4 times 3 times minus 3 all over 2 times 3. Right? We're not going to actually calculate that on our calculators though, we're just going to show that we demonstrate that we understand that that is the method, but actually what we can then do is we can use the equation solver on our calculator, right, to solve our polynomial degree 2, and we just pop those coefficients in, 3 minus 4 minus 3. Okay, so we get two values of 2, we get 1.8685 and minus 0.535. Okay, now that fits with our graph because we've got two turning points. We've got this one here, which will be the 1.8 because it's between 0 and 3, and then one between 0 and minus 1, which you can see here will be the minus 0.53. So if we're looking for the maximum distance from the hand, we've found that that occurs at this time, but to find the distance, so the max distance, we have to substitute that in to find out what s is, because s is what's representing our distance. So the max distance is 0.6 times 1.8685 plus 0.4 times 1.8685 squared minus 0.2 times 1.8685 cubed. So we're going to use as much accuracy as we can right before the end of the question because we're going to use in this answer, so I've not rounded it early. I'm going to use my full accuracy until I get a final answer. So I take my equation and I pop that into my calculator. So we've got 0.6 times 1.8685 plus 0.4 times 1.8685 squared minus 0.2 times 1.8685 to the power of 3, and we get a final answer of 1.21 meters. Okay, and that I have rounded to 3 significant figures because it is a final answer. So that is how far, it's the maximum distance that it gets from the child's hand, and we can see it's on this graph because it's the turning point of the graph. Okay, so that's what lesson 3 is all about. Again, there's only one example for this. What I would advise you to do now is going to be exercise 11C for you to have a go at, and there's several questions there. I'm going to say let's have a go at the odd questions on that, right? There's only 6 questions, so there's only 3 to do, and if you need a bit of extra practice, have a go at the evens as well.